Okay, this is the review for test number 2, first 6 weeks, fall 2015. So if you watch this one, sorry, I paused it, but if you watch this in the future, this review still may be good for future tests for the second 6 weeks, even though the test will change. But this is the one that we're going to do right now, and I'm going to go through a few problems on this review. Here's the first one. This one just simply says to evaluate the expression. It's 3,500 times 3 raised to negative 2.2. It's a straightforward question, very easy. This question could be both open-ended and multiple choice. Either way, the quickest way to do this is to just simply put it on the calculator. So if I'm going to do this on the calculator, I'm just simply going to do 3,500 as my constant, and then I'm going to use parentheses. I'm going to do 3 raised to the negative 2.2, and then I'm going to close it. Now notice how I closed it. I want to enclose 3 raised to the negative 2.2. Now I'm going to hit enter, and there's my answer right there, 312.1777274. And again, in a multiple choice situation, you would have to match that answer accordingly. If you're writing this out open-ended, then you just simply write out 312, whoops, I mean that happened, 312.177. My standard rule is to round to 3 decimal places unless you're told otherwise. Pretty straightforward question. Hopefully, no one's going to have any big issues with that. And yes, the test will contain a few of those. Sorry about that. The test will contain a few questions like that. Okay, next question. Move it over a little bit. This one says to solve the exponential equation. Solve the exponential equation. 350 over 1 plus e to the negative x equals 325. And again, there are a couple of ways to solve this. This could also be a multiple choice type question. Either way, how you solve it is going to be the same as far as your answers are concerned. We're going to solve this one using 2 methods. The first one is to actually do it by hand. If we wanted to do it by hand, then here's what we would need to do. First thing, notice that the x is in the denominator right there. All right, if it's in the denominator, we want to change that. So if we're going to change that, we've got to get rid of it, or in other words, move it from the denominator. The only way to do that is to multiply both sides by 1 plus e to the x. Now, if we want to write it out officially, 1 plus e to the negative x, times 350 divided by 1 plus e to the negative x is equal to 325 times 1 plus e to the negative x. Now, you're not required to have to write all that out, but I did it formally to show you that these go away, and the result is 350 is equal to 325 times 1 plus e to the negative x. All right, now, this is a basic exponential equation, and for us to solve this, we're going to need to turn it into a logarithm. But before we do that, we need to see that our e to the x, which I'll underline in green right here, is enclosed inside of parentheses. So we're going to have to take care of this parentheses and do some other work too. Now, in your math classes, your basic method, when you have something times a parentheses, is to distribute that number across. That's normally the thing to do. In this particular case, distributing 325 across is not the best method for what we want to do. Remember, we want to get that e to the negative x outside of the parentheses. And if we distribute, we get rid of the parentheses, but we don't really change anything. The better thing to do is to divide both sides by 325. Okay, and remember, that's going to cancel out, so we're left with 350 is equal to 1 plus e to the negative x. 350 is 1 plus e to the negative x. Right now that we're there, again, we want to work this down to where we have just e to the negative x is equal to a number. Base power equals answer. So, let's do this correctly. My mistake here. I'm glad I made that mistake on film here so that we can correct that. 350 divided by 325 ain't correct. Let's pull the calculator up and do it correctly. That's your teacher's fault. 350 divided by 325 is 1.076929, et cetera, et cetera, et cetera. Now, we can either write that down or leave it alone. I'm going to choose to write this one out. All right, 3 decimal places, 1.077 is equal to 1 plus e to the negative x. Okay? All right? Class, give me a nod. Am I correct so far? Yeah, good. Okay? Now, I want to get this e to the negative x, and I want to get it by itself. So, therefore, I'm going to have to subtract 1 from both sides. So, I'm going to subtract 1. So, if I do the old algebra there, and again, I'm going to pull the calculator up. 1.077 minus 1. Of course, we could have done that in our heads. It's 0.077. Is equal to e to the negative x. So now I have a base power equals answer. Base power equals answer. But some of y'all have trouble seeing it like that. I'm just going to rearrange it. E to the negative x is 0.077. Again, base power is equal to answer. So what do? If we have a base raised to a power is equal to an answer, we want to turn it into a log with the same base raised to the answer is equal to the power. So what we want to do with this then, the page a little bit more, is I want to do log with the base of e, 0.077, is equal to negative x. Now log base e is the same thing as the natural log. All right, now notice that this thing is equal to negative x. We want it to equal x, so we're going to multiply both sides by negative 1. So we get the negative of the natural log of 0.077 is equal to x. Therefore, x is approximately equal to, pull the calculator up, I want to do the negative of the natural log of 0.077. And I get 2.563949857. And again, we're just simply going to round to 3 decimal places, so that's 2.564. 2.564. So that's correct. I'm going to rewrite it towards the top here. So if you haven't gotten this down, you'll need to stop the recording and go ahead and copy this down, because I'm about to scroll back up. Again, our answer was 2.564. So x is approximately equal to 2.564. Actually, I'm going to rewrite it in blue over here because I'm about to cover this with the calculator. X is approximately equal to 2.564. It should be. Okay, now if I'm correct, I should be able to take 2.564 and plug it in for x and work it out. Okay, let's get this right on film. 5.6. I should have 5.64. Thank you for that correction there. It's a Monday for me, even though it is Tuesday. Okay, now, again, is this the only way to do this type of problem? Absolutely not. Some of you prefer to use the calculator. It's not wrong to do that. If you're going to use the calculator, and what you need to do is go to the y equals, and you're going to need to put it in correctly. And to put it in correctly means you need to set it equal to 0. And this is where sometimes people have troubles with this stuff, right? Now, I guess we can go one way or another, but I'm just going to do it like this. What I need is parentheses 350, and I'm going to divide it by 1 plus e, wrong one, clear that. This calculator up here on the screen is a little blurry. 350 parentheses 1 plus e raised to the negative x. But I want to put 2 parentheses because I want to put 350 divided by – 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 . 2 my calculator work here. Yeah, I want to put 350 divided by 1 plus e to the negative x, all in parentheses. And then I want to subtract 325 from that. Now, the reason I want to do this is if I want to find x, all I need to do is now find the x-intercept. I want to find the x-intercept. So me, what I do is I hit zoom 6 and just put it in a standard window just to see if it'll graph. Now, it probably is graphing. There it went. But I was about to say, if you can't see it graph, you just need to change your window. That doesn't mean that you did it wrong. You just need to change your window. So if I look up there, and of course one of the standards is to go to your table. This board doesn't want to cooperate here. Second graph. All right, if you go to the table, what we want to see is where we have a 0 for a y. And if you scroll through here, you have a 0 somewhere between 2 and 3 on the x-axis. And again, if we look at it here, you can see it crosses somewhere between 2 and 3. And so another method is to trace it. Go to the 0, enter. Right, and then it says left bound. Well, remember what you want to do is line up the little, I call it the blinking spider, somewhere to the left of 2 on the x-axis. All right, and I know if you read up there in the bottom left, it says x is 0.45 something. So I'm just going to keep right arrowing until I get close to 2. Of course, using the smartboard takes a little while. All right, it's somewhere close to 2, so I'm just going to mark it. And notice this nice calculator gives you the vertical bound. I want to mark it to the left. Now I want to mark it to the right. See the little spider jumping up? Just need to make sure I'm marked somewhere to the right, and I am. And then I hit enter. It tells me to guess. I don't know why. All right, but if you look at that, and again, it's a little blurry on the calculator, but on the right-hand side it says 2.56494, or in other words, 2.565. Now I know we got 2.564, but rounding is going to get it like that. Either way works. Whichever way is preferable to you works. I spent a long time teaching this part of things, but in reality, if you know what you're doing, this should not take very long. This should take less than a minute to solve on this. All right. Got how to do that. Okay, the next question. Find the value of x. 8 natural log of 3x is equal to 13. Straightforward question. Again, we'll do this by hand and by the calculator. So if I want to work this out by hand, 8 times the natural log of 3x equals 13. Natural log, for some people who need to see this, can be rewritten like this. Again, you're not required to have to do it like this. A lot of people, if they're going to do the base log, base answer, power, converts to base power answer, they like to see it written in this form, the log base e. It just makes it a little easier to comprehend. Either way, it doesn't matter. So our goal here is to funnel this down where we have a log base e of some answer is equal to a power, and then convert it. That's our goal, to get it down to that point. To get it down to that point, though, we've got to take care of this x. Does it make sense? We're going to divide both sides by 8. So if we do it that way, we're going to have log base e of 3x is equal to 13 divided by 8. Now we can figure out what 13 over 8 is with the calculator in just a second. But right now we're just going to leave it like it is. Okay, now we're in log base answer power becomes base power is equal to the answer. So e raised to the 13/8 power, whatever 13/8 is equal to 3x. Therefore, just move to the right here, e raised to the 13/8 power, that whole thing divided by 3, is going to be equal to x. E raised to the 13/8 power divided by 3 is going to be x. Now we'll put it up here on the calculator. Clear it off. Okay, E, I'm going to raise it to the 13/8. That's 5.0784, et cetera, et cetera. Then I'm going to divide that by 3. And I get an answer of 1.6928. So therefore, that should be 1.693. So X is approximately equal to 1.693. And again, this could be a multiple choice question, or it could be an open-ended. The method is just the same. If we're going to do it with the calculator, we need to pull the calculator up. Let's go to the y equals, clear all that out. Now what we need to do is put the function in, setting it equal to 0. This is pretty straightforward. 8 times the natural log of 3x. And then I'm going to subtract 13. And again, I assume 6 it just to get it in its normal window. It obviously has an x-intercept. You can look at it, it's somewhere between 1 and 2. Since it's not exactly 1 or it's not exactly 2, it's not going to give it to you in the table. Again, if you just simply go to the table, you know it's somewhere between 1 and 2, but you're not going to know exactly. So what you want to do is go to the trace feature, go to the 0, and again, left bound it and right bound it. We know we need to be between 1 and 2, so if you look on the bottom left, left bound is 0, and see those numbers going up. You see the little spider, it appears on the screen, and it's vertically to the left. Now we want to mark it vertically to the right, just hitting the right arrow. And then it tells you to guess. I don't know why it tells you that. I used to joke, say, well, maybe they give you a prize. But anyway, again, if you can read the screen up here, it says 1.6928063 or 1.693, which is what we got before. So that's pretty straightforward, not a big problem. Clear that calculator out. Move it down. Next problem. The amount of time t in years required for a certain radioactive material to decompose is the natural log of r minus the natural log of a over k. So we have 4 variables right there. So we need to know what t, r, a, and k are going to be. And it says where r is the mass of the substance remaining after the decomposition. I'm going to underline that in red. It's the substance remaining, and A is the original mass. I'll underline that in blue. And better yet, it tells you what K is. What is K? K is a constant related to the particular material. So the problem says to find the time required for 48 grams of radioactive substance to decompose only 16 grams if K is negative 0.511. Well, it says to find the time. If you look up there, time is T. So T is equal to the natural log of R minus the natural log of A over K. So as long as we know what R, A, and K are, we're good. Well, as it turns out, K is real easy. It tells you K equals negative 0.511. That's pretty straightforward. Not a big problem. Now we need to know what R and A are going to be. Well, remember, R is the substance remaining, A is the original mass. So it says, find the time required for 78 grams of a radioactive substance to decompose so that only 16 grams remains. So we have 2 numbers, underlined in blue, 48 and 16. We need to know which one of those is R and which one of those is A. Well, again, R is the substance remaining. So if you read the problem, we start off with 48, we have 16 remaining. So we need to have the natural log of 16 minus the natural log of 48. Not the other way around. Because, again, R is what's remaining, A is the original. So if it says 48 grams to decompose to 16, 48 is the original, 16 is the amount left over. So now it's just calculator work. Again, well, let's see, let me do this. Let's see if I can, I'm going to move this up a little bit. I'm going to have to erase all my, so if you didn't get that, you'll have to rewind the film a little bit. Hang on a second. Group these together. Move them over here. Now I can put my calculator up. Hopefully it's going to read that. So I have the natural log of 16 minus the natural log of 48. Gives me that number, and I'm going to divide it by negative 0.511. I get 2.149926, or T is approximately equal to 2.15. 2.15 even once. All right, so it says find the time. Well, now, again, in a multiple choice situation, you shouldn't have to worry about this, but in units, it tells you the time is years. So it takes 2.15 years to decompose here. And you could have probably put this one in the calculator, but I'm going to leave this one alone on this. Then we'll look at this one. So solve the exponential equation. I'm going to write a little bit bigger here. 6e to the negative 0.02x plus 32 is equal to 34.4. We'll put this one in the calculator first. That means I'm just going to make this a little smaller. If I do this one in the calculator, again, put it in, set it equal to 0. So I have 6 raised to the negative 0.02x plus 32. 6 raised to the negative 0.02x plus 32. And then I'm going to subtract 34.4. Graph it, see if we can physically see an intercept. Well, that one's going slow. And by the slope of it, or the decrease, it doesn't look like we see an intercept. So in order for us to use our trace feature, we actually have to physically see an intercept. So you have a couple of choices. One is to zoom out. Me personally, knowing where it's going on the x-axis, I'm going to extend my x max to 30 and just see what it looks like. Now, zooming out may have been the thing to do. I don't know. Right? It's going to be close. So, again, I'll make that 50 right quick. I've been told there's a way to speed these graphs up, but I don't know what it is, how to do it. Right? So I clearly, if you look at the screen up here, you can see it just barely dips below the x-axis, but that's good enough to be able to use the trace feature. Right now, so my spider's to the left, I'm just going to hit enter. Then I'm going to run it, but I need to run it way over to the far right to make sure it's clearly below the x-axis. Right? It's clearly below there. And I know that by looking at my y coordinate on the little screen on the bottom right. It's a negative number. So I marked it and I hit enter. And I know my 0 is 35 point, looks like 0.869, 0.889. I'm going to write it down as 35.867. 35. And again, now that's by looking at the calculator, and I'm not sure the calculator was a little blurry, but that's okay. You know, again, in multiple choice, we know it's going to be 35.8 something. Right now, we'll solve this by hand right quick and see if we come up with the same type of number. Solving it by hand means that we have to subtract 32 from both sides and divide by 3. So I'm going to write it like this. E to the negative 0.02x is equal to 34.4 minus 32 divided by 6. I think I said divided by 3 earlier. I meant by 6. Now again, you may want to stop the recording and copy this down so that you can get it. But again, what I did was I moved my 32 over through subtraction, and I divided both sides by 6. I did it all in one motion there. Again, you need the arrows stop the recording and recopy it. I'm going to pull them out of there, just erase them. Now 34.4 minus 32 divided by 6, that's some number, but we'll handle that in just a minute. So this is E, erase all that. Well, I went through the log that earlier, so you can go back in the recording and find out where I did that and go back through it. But this is base power is equal to answer. So I know then that the log with a base of whatever 34.4 minus 32 over 6 is equal to negative 0.02x. Log base E is the natural log. Right? So what I'm going to do then, I'll go ahead and pull the calculator up. And I know 34.4 minus 32 is a number. I'm going to divide that by 6. So I get 0.4. So here's what I'm going to have. My answer is going to be the natural log of 0.4 divided by negative 0.02 is equal to x. The natural log of 0.4 divided by negative 0.02 is my answer, and that's, wow, something went wrong somewhere. Your teacher is bad off. I got 35.867 on the calculator, and that got me 45.8. So your teacher has gone wrong somewhere. 34.4 minus 32 divided by 6 is 0.4. So the natural log of 0.4 is that number. And then if I take the answer and divide it by negative 0.02, I get 45.8. So let's see where I went wrong. Any suggestions from the students here? Okay. Well, then something went wrong with the calculator. So let's go back and let's see if I put this in correctly. I got 6 raised to the negative 0.02x. Here's what I got. Here's my problem. I have 6 raised to the e raised to the negative 0.02x. So I have incorrectly typed this thing in. I don't know if y'all can see it from where you are, but if you look at what I typed in, I actually have this. I have 6 raised to the e raised to the negative 0.02x. So it's like 2 exponents. So I apparently typed it in wrong. So let's clear that and let's type it in correctly. 6e raised to the negative 0.02x. Okay? 6e raised to the negative 0.02x plus 32 minus 34.4. And I'm going to zoom 6 it just for a second. We already know that we need to go out 45. So what I'm going to do is I could zoom out, but I like my window change instead. I'm going to change my X max to 60, and I'm going to change my scale to simply 5. That way it should be fairly clear to see. Well, again, it's not fairly clear, but it's clear enough. Again, if you're having trouble seeing it from where you're sitting, that's okay. If you look over here, and if you look at the screen while you're viewing this, you'll see it clearly crosses the x-axis. So I'm going to use the trace feature. Again, I'm going to mark it to the left. And it's going to take me a second here. I'll mark it to the right. This is why it's good to do it by hand. All right, that gave me 45.814537, which is approximately 45.8. And I know I didn't round 3 decimal places, so I'm going to leave it alone. So I'm glad I actually made that mistake on this problem. And I'm sure someone watching that from the very get-go is going to say, they put it in wrong, it's going to be all wrong. But we caught it. So this is going to be a good learning thing for all of us.